Hello students, today we are going to show that 1 plus 2 plus 3 plus etc. n that is equal to n into n plus 1 by 2 where n is a positive integer by using principle of mathematical induction method in discrete mathematics. So what is given? P of n equal to 1 plus 2 plus 3 etc. n which is nothing but n into n plus 1 by 2. Okay, so we need to verify this series is true or not by using principle of mathematical induction method. So what is step number 1? Step number 1, we must to prove that P of 1 is true. Okay, so how to prove P of 1 is true? We consider given equation is 1. Okay, so substitute n equal to 1 in given equation. So we get what? If we substitute n equal to 1, we get P of 1 equal to, here you get what? 1 into 1 plus 1 by 2. So in numerator we get 2 by 2. 2 by 2 is nothing but 1. So therefore P of 1 equal to 1. So P of 1, if we substitute n equal to 1, you see P of n, if we substitute n equal to 1, we get a P of 1 value is 1. So therefore what? So P of n is true. Okay, so P of n is true for n equal to 1. If we substitute n equal to 2, here you get what? 2. If we substitute, okay, if we substitute n equal to 2, we get what? 2 into 3 by 2. So you get 6 by 2. What is 6 by 2? 3. So we consider two terms given expansion. So first to two terms. What is first to two terms? 1 plus 2, that is equal to 3. Therefore P of 2 also true. Okay, but here we no need to substitute n equal to 2. Okay, so we assume that step number 2. What is step number 2? Step number, so now we go for step number 2. Okay, so what is step number 2? Assume that n equal to k, which means P of k is true. Okay, so we only assume P of 2. That means what? P of k equal to 1 plus 2 plus 3 plus etc. plus k, that is equal to k plus 1 by 2. So we only assume up to k is true. Okay, so now we go for step number 3. What is step number 3? We need to prove that what? P of k plus 1 is true. Okay, once it is true, remaining value everything is true. Okay, so now substitute n equal to what? K plus 1 in equation number 1. So we get, if we substitute n equal to 1 in the given equation, we get P of k plus 1, that is equal to 1 plus 2 plus 3 up to what? K plus 1 numbers are there. Okay, so we know what is up to this. This is nothing but equation number 2. So k into k plus 1 by 2 plus 1. Okay, so now we simplify this equation, which means you take LCM here, you get what? 2 is LCM. So k into k plus 1 plus 2 into k plus 1. Okay, now we need to simplify this equation. How to simplify this one? So here we see k plus 1 is common, right? So we take k plus 1 is outside. So we get k plus 2, okay, by 2. So this is nothing but what? Hereafter we are unable to simplify this. So now we will verify this expansion is true or not. Substitute k equal to 0. If we substitute k equal to 0, we get what? Here 0 plus 1. Here you get 0 plus 2 by 2, that is equal to 2 by 2 equal to 1. So you get first, again we substitute k equal to 1 in this expansion. So we get what? Here you get 2, 3 by 2 3s are 6 by 2. 6 by 2 is nothing but 3 only. So you consider first two given series. First one is 1 plus 2. So that is equal to 3. So therefore what? This expansion is therefore what? Which is true. Okay, so if is so therefore if we substitute k equal to any real numbers, we get the given expansions. Okay, so therefore P of n is true. Okay, so P of n is true for n equal to k plus 1. Okay, by using principle of mathematical induction method, we get what? P of n is true. Okay, we get P of n is true for all to what? 1, 2, 3, x set of all natural numbers. Okay, so which means the given series is what true by using principle of mathematical induction method. I hope you are enjoying this session. Thank you.